Hello everyone. I am Muhammad Bilal Khan, a research student at School of Mechanical and Manufacturing Engineering, National University of Sciences and Technology, Islamabad. In this video, I'll be demonstrating the steps involved in biodiesel production. Here, biodiesel is produced by the transesterification of vegetable oil. For this reaction, the chemicals required are any generic vegetable oil, methanol, and potassium hydroxide. We start out by weighing a sample of our vegetable oil. My sample weighed around 255 grams. This weight was used for computing of the mass of methanol and catalyst required for the reaction. The weighed oil was then transferred to a round bottom flask. Next, a 57-gram sample of methanol was weighed into an Erlenmeyer flask and 5 grams of potassium hydroxide catalyst are added. The solution was stirred using a magnetic stir bar and heated gently over a hot plate until everything dissolved. This solution is then set aside for later use with the cover over the flask. The round bottom flask containing the oil is set in a water bath that is heated to the reaction temperature, in our case 60 degrees Celsius with strong stirring. Once the temperature reaches 60 degrees Celsius, as shown here, the potassium hydroxide in methanol solution is added into the reaction mixture and a condenser column is set to avoid the loss of methanol through evaporation. The reaction is allowed to continue for 1 hour. Let's go over the process. The basic reaction going on here is the trans-esterification reaction. Vegetable oil, which consists of mostly triglycerides, react with methanol and produce fatty acid methyl esters and a byproduct glycerol. The reaction equation is shown here. Although, according to the equation, only 3 moles of methanol are required, an excess should be added to drive this reversible reaction forward. The strong base in methanol essentially results in the production of a highly active methoxide ion, which attacks the carbonyl carbon in the ester group. After the shifting of electrons, the ester linkage reestablishes but with the methyl group. The other carbon chain, in our case glyceride, reacts to reform the catalyst, which then repeats the process. This continues until all of the triglycerides are converted to methyl monoesters. The reaction is dependent not only on the amount of methanol and catalyst but also on the temperature, the rate of stirring, and water content. The presence of water causes a yield loss due to the formation of soap. It should be made sure beforehand that there is very little moisture in any of the reactants. Strong stirring is required because methanol is immiscible in oil and without stirring would simply form a layer on top. The reaction mixture is allowed to cool before being transferred to a separatory funnel, where it is allowed to settle over 7 hours. Glycerol, catalyst, and unreacted methanol, as well as other impurities, sink to the bottom, while biodiesel forms the upper layer. The lower layer is then extracted and discarded, and biodiesel's crude sample is measured to assess the crude yield before washing. Biodiesel is washed with distilled water several times. First, a 250 milliliter of water is added and the funnel is capped, gently shaken and vented, and the water layer is extracted. For the second time, again 250 ml of water is added and the funnel is shaken vigorously to form an emulsion, which then again is allowed to separate. The water layer is then extracted. For a third time, concentrated salt solution at 50 degrees Celsius is added to extract as much water as possible from the emulsion, and the lower layer is discarded again. Biodiesel is washed a few more times until the extracted water layer is clear. Washing is done to rid the biodiesel of unreacted methanol, monoglycerides, and most importantly soap. The sample is then weighed into a beaker. Biodiesel is then heated over a hot plate with strong stirring until the temperature reaches 105 degrees centigrade. This temperature is maintained for a few minutes. This is done to remove moisture from the biodiesel. The product is then allowed to cool and weighed again. In total, I used about 255 grams of oil and was able to produce a 201 gram sample of biodiesel, which approximates to a chemical yield of 79%. This is it for today's video. I hope this demonstration was helpful. Thank you for watching.